So we would like to do an example of triple integration in spherical coordinates, where we want to compute the integral of xy over a certain part of the unit ball. The unit ball is the ball centered at the origin with radius 1. And we want to specify one octant. And that is the one for which x is greater than or equal to 0, y is less than or equal to 0, and c is less than or equal to 0. So in some sense, we're integrating over 1/8 of the unit ball, the 8th, which is specified by these inequalities. So I'm not going to try to sketch this domain in 3D, because as we're going to see, understanding what bounds need to be used is going to require just 2 dimensions. So the first and most important thing we have to take care of is to describe this domain in terms of spherical coordinates. So we would like to say that U is all the rhos, thetas, and phis, and now give the description. This part here is to understand where rho is going to be. So rho is going to be certainly between 0 and 1. Why? Because we're talking about 1/8 of the unit ball, which is obtained by intersecting an octant by the unit ball. And certainly rho in that part varies from 0 to 1 for all possible values of theta and all possible values of phi that we are going to find. So now let's discuss a little theta. So how do we find theta? For theta, I'm going to just draw the xy plane, because remember that theta is defined as the angle between the radial, the projection of the, so it's defined as the angle between the segment that connects the projection of your point to the xy plane and the positive x-axis. So it's in some sense this angle right here. Now, what we should be looking at for theta is the inequalities on x and y. So x is greater than or equal to 0, and y is less than or equal to 0, which pretty much brings us in this territory right here. Okay, and since theta starts counting like this, when we reach this point here, theta is 3 pi over 2. And when we reach this point here, theta is 2 pi. So what is the conclusion here? That theta should be between 3 pi over 2 and 2 pi. Please notice that you could have also done from negative pi over 2 to 0, but this is just because you have a wide variety of choice of theta. Theta is not uniquely defined. However, this is the simplest way to set theta. And now let's talk a little about z. To understand how z works, again, I'm going to draw a specific plane. So this time I'm going to draw the yz plane and understand where zeta is. And pretty much, if I look at this inequality and that inequality, then I can see that the area which is of interest to us is where y is less than or equal to 0 and z is less than or equal to 0, which is this part right here. Now, we have to remember how phi is defined. How is phi defined? Phi is defined as the angle that the angle between the positive z-axis and the segment that connects your point to the origin. And what is peculiar about phi is what? That when you start here, phi is 0. Let's say here, if this is the bisector, phi is equal to pi over 4. When you reach the part with z is equal to 0, you get that phi is equal to pi over 2. Then here, you have that phi is equal to 3 pi over 4. And when you get here, phi is pi. So on the negative z-axis, phi is pi. But the tricky part is that now you start, the moment you start coming back, you're not actually measuring this angle. No, that's not what you're measuring. You're actually measuring this angle. So it's, oops, I erased something. So sorry about this. Let me put back my lines here. And let me put back the segment that I was discussing. So I was discussing this, and I was saying that this is the angle that we're actually measuring. This angle right here. That's why phi is always between 0 and pi. It never exceeds pi. And this is very different than what happens with theta. So now, in the specific example where we are right here, when we're interested only in this part right here, then phi right here is equal to pi, and here it's equal to pi over 2. And you get everything else in between. So what is the range for phi? The range for phi is going to be pi over 2 to pi. And now we have the domain, and that's the most important part. So it's a box with respect to spherical coordinates. So we can now write our integral. So it's going to be 0 to 1 d rho. 0, not 0, I'm sorry. 3 pi over 2 to pi d theta, and pi over 2 to pi d phi. How about the integrand? The integrand is x is equal to rho sine phi cosine theta, and y is rho sine phi sine theta, and we shouldn't forget the Jacobian, which is rho square sine phi. This integral does split. So we are going to have integral from 0 to 1 of rho to the 4th d rho, and integral from 3 pi over 2 to, I'm sorry, not pi here, that should be 2 pi, to 2 pi of sine theta cosine theta, and finally the integral from pi over 2 to pi of sine to the 3rd phi d phi. Okay, all of these integrals, with the exception of the first, have some interest in their computation. So for the first one, the antiderivative is rho to the 5th over 5 from 0 to 1, and the answer is 1/5. For the second one, let's do a substitution. So the substitution will be u is equal to sine theta du is equal to cosine theta d theta. And the integral will go from, so it will be the integral of u du. And now we have to plug in 3 pi over 2 in sine theta. When you plug in 3 pi over 2, you find the sign is -1. And sine of 2 pi is 0. So this is going to be u squared over 2 from -1 to 0, which is -1/2. And the last one is also quite interesting because we can rewrite this as sine square of phi times sine phi d phi. This can be further written as pi over 2 to pi of 1 minus cosine square of phi sine phi d phi. And now we can do the substitution. U is equal to cosine phi. Du will be minus sine phi d phi. So I will put that negative sign in front. I will have 1 minus u squared du, and let's be careful with the limits. So plug in pi over 2 for cosine. Cosine of pi over 2 is 0. Plug in pi for cosine, that would be negative 1. So this will be the integral from negative 1 to 0 of 1 minus u squared du, because I incorporated the negative sign, and that will be u minus u cubed over 3 from negative 1 to 0, and that will be minus negative 1 minus minus, so plus 1/3. So this will be minus 2/3, and with the extra negative sign, 2/3. So I hope I haven't made any numerical error. So if I multiply which numbers, so I need the 1/5 from here, the negative 1/2 from here, and the 2/3 from here. Then what I will find, the 2's are canceling out. I think I will find negative 1 over 15 is the final answer. And if somebody looks at the negative sign makes complete sense, because in the domain that we had, the x is greater than or equal to 0, y is less than or equal to 0, which means that the integrand is negative, and it only makes perfect sense that the integral will come out to be negative. Of course, one has to realize that the most important part here is to actually find the bounds, and one has to really revisit the explanation that we did by using the corresponding axes, by isolating the x and y system and the y and z system in order to find the bounds for theta and phi. So I hope that this is helpful. Thanks for watching.